All right, let's crack open the case on computer hardware. We're going deep on this one, folks. A real journey into the heart of your computer.
It's fascinating, isn't it? Even those cutting-edge computers, the kind that can render these amazing, like 3D worlds or analyze these huge data sets.
Yeah.
Well, they're built on actually a pretty simple idea. It's a system, you see, of interconnected hardware components,
Okay.
and each one has a very specific job to do.
So it's not just a jumbled mess in there.
Not at all. Think of it like a well-coordinated team, each member, with their own expertise,
Gotcha.
and leading this team, uh, calling the shots, making sure everything's running smoothly.
Yeah.
That's the CPU, the central processing unit.
The CPU, okay. I've always heard that called the brain of the computer.
Right.
Is that just a simplification or is there more to it?
It's a good analogy. The CPU is where the magic happens, you see.
Okay.
It executes instructions, crunches numbers, and basically orchestrates the flow of information between all the other components. It's like, uh, imagine your computer is a bustling city, right?
Okay.
The CPU is that central command center. It's directing traffic and keeping everything running smoothly.
So pretty important then.
Oh, absolutely.
But how do we know if a CPU is good? Is it all about speed?
Well, speed is definitely a factor.
Okay.
We measure CPU speed and clock speed, which basically tells us how many cycles it can perform per second. Imagine it like a heartbeat.
Okay.
A faster heartbeat means the CPU can process information more quickly.
All right, so faster is better. That makes sense. But I've also heard about cores. What role do those play?
Ah, cores. Think of them as specialized teams within the CPU. Imagine your CPU as an octopus.
An octopus.
Yeah, each core is like a separate arm tackling a different task.
Mm,
So with more cores, your computer becomes a multitasking master.
okay.
It can juggle demanding applications
Yeah.
like, video editing or running complex simulations effortlessly.
So if I'm like a gamer or someone who works with resource-intensive software,
Yeah.
more cores are better.
You got it. More cores allow your computer to handle those tough tasks without breaking a sweat. But it's not just about raw power.
Right.
It's also about how efficiently these components work together.
So there's more to it than just plugging in the fastest CPU and calling it a day.
Precisely. All those components need a place to connect and communicate.
Okay.
That's where the motherboard comes in. It's the foundation of your computer.
The motherboard, okay, it sounds, I don't know, kind of basic, like a plain slab of something. Is it really that important?
Oh, don't underestimate the motherboard. It's the central hub that connects all your components, allowing them to share power and data. Think of it like the nervous system of your computer. It relays signals and coordinates all the activity.
Okay, so is it just a matter of finding a motherboard that fits all the components? Are they all the same?
Not at all. Motherboards come in different sizes and layouts, known as form factors.
Okay.
Get your ATX, your micro ATX, your mini ITX,
Right.
each one designed for specific types of builds. So choosing the right form factor is super important because it determines the size of your case and the components you can install.
It's like choosing the right foundation for a house then.
Exactly. You got to consider the size and layout based on your needs and the components you want to use. But there's even more to it than just size.
Oh.
The motherboard also houses the chipset, which is like the motherboard's um, traffic controller, I guess you could say.
Okay.
It dictates how data flows between the CPU, RAM, and other components. So a high-end chipset can really boost your system's performance, especially for demanding tasks like gaming or video editing.
So the chipset's like a hidden hero kind of working behind the scenes to optimize performance.
Precisely.
Hmm.
And let's not forget about the BIOS-CFI, which is like the control panel for your motherboard.
Right.
So for those who really love tweaking and optimizing their systems,
Yeah.
the BIOS-CFI is a real treasure trove of settings. You can overclock your CPU, fine-tune your fan curves. You can even enable advanced features that can squeeze, every bit of performance out of your hardware.
So the motherboard is more than just a passive connector.
Absolutely.
It plays an active role in how the whole system performs. And for those who like to, tinker,
Right.
it offers a lot of customization options.
Exactly. But we can't forget about memory.
Oh, right.
How does a computer actually remember things?
Yeah. How does it hold on to the information it needs to work with?
That's where RAM comes in, right? Random access memory.
Yeah.
I've heard that it's like the computer's short-term memory, but
Yeah.
what does that really mean? It's a good analogy. But let's delve a bit deeper. Imagine RAM as your computer's mental workspace.
Okay.
It's where the CPU stores the data it's actively using, allowing for lightning-fast access. Think of it like having all your tools and materials laid out in front of you while you're working on a project.
So when I have multiple programs open, or when I'm, I don't know, editing a video,
Yes.
RAM is what keeps everything running smoothly without, like, lagging.
Exactly. The more RAM you have, the more information your computer can juggle at once. And if you're working with large files or complex applications, having enough RAM can make a huge difference in performance.
Okay, that makes sense. And how much RAM is enough? I mean, do I need to max out my system with as much RAM as possible?
Well, it depends on your needs. Modern computers typically come with anywhere from 8 GB to 32 GB of RAM. For everyday tasks like browsing the web or working with documents, 8 GB might be sufficient. But if you're a gamer, a content creator, or someone who runs resource-intensive applications, you'll want to consider 16 GB or more.
So it's like having a bigger desk space, more room to spread out your work means you can be more productive.
Precisely. And speaking of storing things, RAM is great for temporary storage.
Right.
But what about all those files, photos, videos, and software you want to keep for the long term? That's where storage drives come in.
Ah, yes. Storage drives. We've got the classic hard disk drives, or HDDs,
Right.
and the newer solid state drives, or
Right.
SSDs. I've heard SSDs are much faster, but what's the catch?
You're right, SSDs are blazing fast, but they do come at a higher price per gigabyte.
Okay.
They use flash memory, which is like the memory in your USB stick, but much faster and more durable. HDDs, on the other hand, they use spinning disks and mechanical arms to read and write data,
Oh,
which makes them slower but much cheaper for larger capacities.
so if SSDs are like a bullet train,
Yeah,
are HDDs more like, I don't know, a horse and buggy?
maybe not that slow,
Okay, okay.
but you get the idea. It's about balancing speed and capacity. If you want your system to boot up in seconds and applications to launch instantly, an SSD is the way to go. But if you need to store massive amounts of data, like a huge media library, HDDs might be a more cost-effective option.
So it's not just about choosing one or the other.
Right.
It's about understanding the strengths and weaknesses of each type of storage
Absolutely.
and choosing the right mix for your needs.
Exactly. Now, we've talked about, the CPU,
Yeah,
the brain power,
great.
the data storage.
Yeah.
But what about the visual experience? The part that brings your games and movies to life?
Yeah.
That's where the GPU takes center stage.
The GPU, the graphics processing unit. Now, I know this is what makes games look amazing,
Absolutely.
but is it just for gaming?
While gamers love GPUs, they're definitely not just for entertainment. GPUs are specialized processors designed for handling graphics and visual data. They're like the artists of the computer world.
Uh-huh.
They render images, videos, and animations with, incredible detail and speed.
Nice.
They're also essential for professional applications like 3D modeling, video editing, and even machine learning.
Wow. So GPUs are pretty versatile.
They are.
They're not just for making things look pretty.
No,
They're involved in a lot of complex tasks behind the scenes.
absolutely. And just like with CPUs, there's a wide range of GPUs available, from entry-level models for casual use to high-end powerhouses for those really demanding tasks.
Okay, I think we've covered a lot of ground here,
We have.
from the CPU to the GPU and everything in between. But I have a feeling there's a lot more to explore in the world of computer hardware.
You're absolutely right. We've only just scratched the surface. There's a whole ecosystem of components working together to create the seamless digital experiences we rely on every day.
So far, we've talked about, like, the stars of the show,
Right.
the CPU, the motherboard,
Yeah.
RAM, storage, and the GPU.
Right.
But what about the supporting cast? You know, the unsung heroes that keep everything running smoothly.
You're talking about the components that often work, behind the scenes,
Yeah.
quietly making sure everything's operating as it should.
Okay.
And one of the most critical among those is the power supply unit, the PSU.
The PSU. Okay. I have to admit, it's not the most glamorous component. It just kind of sits there in the back of the computer,
Right.
like a wallflower at a party.
But just like a really reliable friend, you don't realize how important the PSU is until it's gone. A good PSU provides clean, stable power to all your components,
Right.
prevents, instability,
Yeah.
performance issues, and even damage to your precious hardware.
So it's not just about plugging in the computer and flipping a switch.
Nope.
There's a lot more to powering these components than meets the eye.
Exactly. The PSU takes the AC power from your wall outlet and converts it into the DC power that your components need.
Yeah.
And doesn't just provide power, it regulates voltage, protects against surges and fluctuations, and make sure, everything's getting the right amount of juice.
So how do we know if a PSU is up to the task? Is it just about getting one with enough wattage to power all the components?
Wattage is definitely important. You need to make sure the PSU can handle the combined power draw of all your components, especially when they're running at their peak.
Yeah.
But there's more to it than just raw power.
Right.
You also want a PSU with high efficiency ratings, which basically means it wastes less energy as heat.
So a good PSU is not only good for your computer's health, it's also good for your electricity bill.
Precisely.
Right.
Now, speaking of heat, we can't forget about another essential supporting player,
Oh, right.
the cooling system.
Right, cooling. That makes sense. All these components working hard, they've got to be generating some heat. But is it, like, really that important? Can't the computer just handle, I don't know, a little warmth?
You'd be surprised how much heat modern components can generate, especially under heavy load. Overheating can lead to all sorts of problems, like performance throttling, system instability, and even permanent damage to your hardware. It's like running a marathon in a thick winter coat.
Okay, that sounds bad. So how do we keep things cool? I know there are, fans, but I've also heard about liquid cooling. Is that just for like hardcore gamers?
You're right. Air cooling with fans is the most common approach, and it's generally quite effective. It's like having a gentle breeze flowing through your computer, carrying away the heat. But for those who want even more cooling power, or who prefer a quieter system, liquid cooling is becoming increasingly popular.
Liquid cooling, huh? That sounds pretty high tech. Is it, I don't know, is it complicated to set up?
It used to be more niche, but these days there are all-in-one liquid cooling systems that are surprisingly easy to install. So instead of air, they use a closed-loop system filled with liquid coolant to absorb and transfer heat away from critical components like the CPU and GPU.
So it's like having a tiny radiator inside your computer, keeping things running cool and, at a comfortable temperature.
Exactly. Now, we've covered the power and the cooling aspects, but what about how we actually interact with this amazing machine? That's where input and output devices come in, often referred to as I/O devices.
Ah, yes, I/O devices, the things that we use to talk to the computer.
Yeah.
And have it talk back to us. So we're
Yeah.
talking keyboards, mice, monitors, speakers, all that jazz.
Precisely. Input devices, like your keyboards and mice, allow us to send commands and data to the computer. Output devices, like monitors and speakers, allow the computer to send information back to us,
Right.
whether it's displaying, stunning visuals
Yeah.
or playing our favorite tunes.
So it seems like there are endless options for I/O devices these days. Anything we should keep in mind when choosing them?
Absolutely. For input devices, ergonomics and responsiveness are crucial.
Okay.
You want a keyboard and mouse that feel comfortable to use,
Right.
provide accurate and precise input,
Yeah.
and don't leave you with aching wrists after a long session.
So it's not just about looks. Functionality and comfort are key.
Exactly. And when it comes to monitors, it really depends on your needs. Factors like screen size, resolution, refresh rate, and color accuracy all come into play.
Yeah.
So if you're a gamer, you'll probably want a monitor with a high refresh rate for smooth motion, while a graphic designer might prioritize color accuracy.
Makes sense. And of course, we can't forget about audio. A good set of speakers or headphones can really enhance the multimedia experience.
Absolutely. Whether you're listening to music, watching movies, or immersing yourself in games, high-fidelity audio can make a world of difference.
So choosing the right I/O devices is about finding the perfect tools for the job,
Yeah.
whether it's creating content, consuming content, or just navigating the digital world.
Well said. Now let's talk about how all these components and devices communicate with each other.
Okay.
The world of connectivity.
Connectivity. It seems like there are, I don't know, a million different cables
Yeah.
and ports and wireless technologies these days. It can be a bit overwhelming.
It can definitely seem that way. But at its core, connectivity is all about enabling communication between different parts of the computer system and the outside world.
Okay.
So we have USB ports, which are like, I guess, the universal language of peripherals,
Yeah.
allowing us to connect everything from keyboards and mice to external drives and smartphones.
USB ports. I think I have a love-hate relationship with them.
I understand. They can be a little bit fiddly at times,
Yeah.
but think about it. One type of port for so many devices.
Yeah.
It's really revolutionized how we connect to our computers.
Okay, fair point. What about networking? How do we connect to the internet and other devices?
For that, we have Ethernet cables, which offer a reliable and high-speed wired connection. perfect for stationary setups where speed and stability are really important. And of course, we have Wi-Fi, which has, liberated us from the tyranny of cables, allowing us to connect wirelessly for seamless browsing, streaming, and online gaming.
Wi-Fi, the magic that keeps us connected on the go. And Bluetooth, that's for connecting wireless headphones and speakers, right?
Exactly. Bluetooth is all about those short-range wireless connections for peripherals like headphones, speakers, keyboards, even smartwatches.
Okay.
It's all about convenience and mobility.
It's amazing to think about how far connectivity has come.
It is.
We've gone from, clunky dial-up modems to lightning-fast fiber optic connections
Right.
and wireless networks that blanket our homes and offices.
It truly is remarkable, and the pace of innovation just continues.
Yeah.
We're seeing even faster and more versatile connectivity options emerging, like Thunderbolt and USB 4,
Right.
which offer blazing fast data transfer speeds and can even power your devices.
It's mind-boggling to think about what the future holds for connectivity.
It is.
Will we ever reach a point where everything is seamlessly connected, like wires and cables are a distant memory?
It's an exciting thought, but for now, let's focus on the present and appreciate how far we've come in connecting our digital world.
Okay. So we've covered the power behind the components. Yes.
How we keep things cool, and
Yes.
the ways we connect.
Right.
Anything else essential to the hardware experience?
There is one crucial element we haven't discussed yet. Something that breathes life into this intricate network of hardware.
Okay, what's that?
Software.
Ah, yes. Software. It's what makes all this hardware actually do something, right? Without it, it's just a fancy collection of inert components.
Precisely. Software is the bridge between us and the hardware. It's the set of instructions that tells the hardware what to do. It's the conductor of the orchestra, you could say,
Okay.
harmonizing all those individual instruments to create a symphony of digital experiences.
So software is pretty important then.
Oh, it's essential.
What are the different types of software? I know there are operating systems, apps, games, and all sorts of things.
You're right. There's a whole world of software out there. But
Yeah.
at the foundation, you have your operating systems.
Yeah. Like Windows, Mac OS, and Linux. These are the platforms that manage all the hardware resources and allow us to run, other software. Think of them as the stage upon which all the other software performs.
So the operating system is like the foundation of the software world, providing the environment for everything else to run.
Exactly. Then we have applications, or apps, which are designed to perform specific tasks. So we have web browsers for surfing the internet, word processors for writing documents, spreadsheets for crunching numbers, and of course, games for entertainment.
Right. And don't forget about all the specialized software for creative professionals, like video editing software, 3D modeling software, and music production software.
Absolutely. The diversity of software is astounding. And there's one more important type of software we shouldn't overlook.
What's that?
Drivers. Drivers. What do those do? I've heard of them, but I'm not sure I understand their role.
Drivers act as translators between the operating system and the hardware.
They're like little interpreters, ensuring that the operating system can communicate with and control the hardware components.
So if I install a new graphics card, I need to install the drivers to make sure the operating system knows how to use it properly.
Exactly. Drivers are essential for making sure all your hardware works seamlessly with the operating system. Without them, your computer would be like a symphony orchestra with musicians who can't read the conductor's cues, a chaotic mess.
Okay, I'm starting to see the bigger picture here. It's not just about the individual hardware components.
No.
It's about how they all work together,
Yeah.
orchestrated by the software.
Right.
It's a complex ecosystem where each element plays a crucial role. It's amazing, right? We start talking about like the CPU and RAM, just these individual parts.
Right.
But it's like the whole system,
Yes.
hardware and software working together, that's where the real magic is.
It is. It's like we've zoomed out
Yeah.
from looking at individual cells
Right?
to seeing like the whole human body.
Exactly. And the human body's always evolving.
Right.
So is computer hardware always evolving? What's coming next?
Oh, absolutely. The desire for faster, more efficient, more powerful computing, it never stops.
So we're going to see like even faster CPUs and more powerful GPUs.
For sure. But it's not just about, making things a little bit better each time.
Yeah.
We're on the edge of some really groundbreaking stuff.
Okay, now you've got me really curious. What kind of like groundbreaking stuff are we talking about?
Well, imagine computers that use quantum mechanics to do
Whoa.
calculations that, like today's supercomputers,
Yeah.
they couldn't even dream of. That's quantum computing.
Quantum computing. That sounds like something out of, I don't know, Star Trek or something.
It does, doesn't it?
What could we even do with that kind of power?
Possibilities.
Yeah.
I mean, they're mind-blowing. Quantum computers, they could change everything.
Oh, wow.
Medicine, material science, artificial intelligence.
Yeah.
They could help us design new drugs that like save lives,
Yeah.
create materials with like crazy properties we've never seen before.
Right.
And AI, oh man, AI systems that are smarter than humans in certain areas.
So it's all like super positive.
It's amazing. But of course, with great power comes great responsibility.
Right, right. It makes you think about the ethics of it all.
Absolutely. We have to develop these technologies carefully,
Yeah.
ethically. We have to think about their impact on society
Yeah.
and make sure they're used for good.
That's a really good point. So quantum computing, that's like one big thing on the horizon. Anything else? Any other, I don't know, mind-blowing advancements we should be like keeping an eye out for?
Well, there's also neuromorphic computing.
Neuromorphic computing, what's that?
It's taking inspiration from the most complex computer we know,
Yeah.
the human brain.
Okay, so we're talking about computers that can like think like humans.
In a way, yeah. Neuromorphic computing, it's about making computer chips that are like the neurons and synapses in our brains.
Wow.
These chips, they're amazing at processing information, just like our brains do.
Yeah.
They can learn, they can adapt, they can make decisions, and they do it super efficiently.
So instead of like programming computers with these strict rules,
Yeah.
we're teaching them to learn and adapt like a living thing.
Exactly. It could change everything. Artificial intelligence, robotics, even brain-computer interfaces.
Yeah.
Imagine robots that can learn from experience, adapt to new environments, or prosthetic limbs that respond to your thoughts.
It's exciting,
Yeah,
but also kind of freaky, right?
it is. I mean, it makes you think about the future of humanity, right?
Yeah.
And our relationship with technology. But one thing's for sure, this journey of computer hardware, it's not over yet.
Yeah.
Not even close.
This deep dive has been incredible.
It has.
We've explored so much, like the inner workings of computer hardware,
Yeah.
from the essential components to these mind-blowing technologies.
Right.
It's amazing to think about what the future holds.
It is. As we wrap up, I want to leave you with this thought. How are you going to use what you've learned today? How are you going to use the power of these machines to achieve your goals, to chase your dreams?
That's a great question. And remember, folks, the world of computer hardware, it's always changing. Always something new to discover, something new to learn. So keep exploring, keep asking questions, and keep pushing the boundaries of what's possible. Until next time, keep on diving.